Hi, and welcome to Module 3. In this module, we stay within the bivariate regression framework, but we add a new wrinkle, the dummy variable. You should be getting pretty comfortable by this point analyzing bivariate regressions and creating estimates from those tools. The dummy variable is a new kind of variable that only takes on two values, 0 and 1. The dummy variable can be independent or dependent, but in this case, for this whole course, we're only going to be using dummy variables as independent variables. Here's how they work. They're useful when you want to split your data into two distinct categories: male versus female, black versus white, rich versus poor, Democrat versus Republican. Then, depending on the value of the variable, 0 or 1, you plug that into your regression equation just like you would for any other variable. So, if x equals 1, then you use your regression equation y equals a plus bx to plug in 1 for x. Then y equals a, which is the y-intercept, plus b, which is the slope, multiplied by 1. If x is 0, you plug in 0. Multiplying the slope by 0 equals 0. So in cases where x is 0, y equals a, which is the y-intercept, plus 0, or the y-intercept. Let's go through an equation using the rural versus urban geography example from the previous module. If we want to expand on that, and we think there are other factors that might influence choices for Republicans and Democrats, one of the factors we might use is gender. We think women tend to vote more for Democratic candidates and Democratic policies than men do. So we create a dummy variable. We code all women as 1 and men as 0. The dependent variable can be the vote share for Democrats, let's say. Let's switch it around, for Democrats in the county. And we create the following regression equation. Y, which is the vote share for Democrats, equals 45 plus 10x. That's our equation. 45 plus 10x. Now for women, x equals 1. So our estimate for the vote share for Democrats is going to be 45 plus 10 times 1, which is 10, or 55. So we think the vote share for Democrats when women are voting is 55%. Let's see how this works for men. In this case, since men equals 0, y equals 45, the y-intercept again, plus 10 multiplied by 0. Well, 10 times 0 is 0. So y equals 45. That gives us an estimate of 45% of votes going to Democrats among men. And this kind of conforms to our expectations. We have an idea that women prefer Democrats to Republicans at greater rates than men do. In this case, among the data and voters in our made-up sample here, we have an estimate that women will vote at a 10-point greater rate for Democrats than they will for Republicans. And that equates to a 10-point greater rate than men will, 55 to 45, which is often how gender distributions break out when we're talking about the vote share for Democrats versus Republican candidates. That's all there is to dummy variables. You multiply by 0 or you multiply by 1. Thank you. I hope you enjoyed this module. Hopefully it was easier than some of the previous ones. And I'll see you in Module 4. Bye-bye.